that we'll be doing. That we couldn't cover that day. So it was given for the homework, expecting that I would cover that much of the course, but we couldn't. So that we'll discuss. So though that question, the last question, that you can do it today. I'm asking the first two questions. Plotting irrational. Okay. Okay, so great. Then we'll start ahead. Now today we'll be doing real numbers and decimal expansion. Okay. Okay, I'll share the video now.
Okay.
Here, can you all see the screen? This is what we did the previous day. Okay. Hello.
Yes,
Hello, please respond.
yes,
You remember this? We plotted this on the number line by magnifying.
yes, ma'am. You yes,
So say no. Why Yukta is looking so confused? Yukta, what happened? Yes, Yukta. Why are you looking so confused? So what's worried? Unmute yourself and see. Still mute. Unmute yourself first. Okay, let's begin now. Real number and decimal expansion. Keep your videos on. See, so many times I've told you, don't let your videos go off. Okay, during the class, keep it on. So real numbers and their decimal expansion. Okay. Now see, children, just by looking at the number, it is very difficult to find whether the number is rational or irrational, isn't that? Just by looking at the number, can you just say whether it's rational or irrational? No, no?
no,
I
ma'am,
don't
not
think so. So, but when we find its decimal expansion, then it becomes easier for us. Okay. When we find its decimal expansion, then it becomes easier because we know that terminating decimal is a rational. Repeating, non-terminating repeating is a rational number. The only irrational number is non-terminating and non-repeating. Okay. So what is the decimal format? Let's write that first. What is the decimal format? This. Like suppose it's for rational number, you're saying. And one side we have irrational. You can note down also if you want, if you feel like. Now suppose rationals are terminating. Terminating means whose remainder is 0. Then you have here non-terminating, okay, and repeating. Non-terminating and repeating. Like suppose if you have 0 0.0, 0 0.333, so 0 point any number you can get repeated. Okay. And for irrationals you have that's non-terminating and non-repeating. Non-repeating. Okay. Like suppose the value of pi. Okay. 3.14159, and it goes on some different numbers. Root over 2. Okay. All non-perfect square numbers. 1.414 and so on. Okay. So these kind of numbers, this is the format for the decimal expansion. Either you get rational or you get irrational. That is just by converting a fraction to a decimal. Okay.
Okay, ma'am.
So now we'll see how do you convert a decimal number to a, if you have a repeating decimal number, okay, how will you convert that to a P by Q form, in a rational form, okay, a P by Q form. Now, show that, let's take a question now, show that 0.33, a very common number, this is decimal point, 0.33 is a rational number. How will you show this? Let's do this now, is a rational number. So
Ma'am,
what we do in this case, we take this value to be x. Okay, so we write 0.3, and since 3 is repeating many times, we'll write a bar over here. Okay, so let's take x equals to 0.3 bar over. Then what do? We multiply this by, now by, we will multiply this by 10. Why 10? Because after leaving one decimal here, we have decimal point. Okay, one digit, after one digit, there is a decimal point. So we'll multiply